Hi friends, today we are going to discuss on a topic refractive index coming in physical pharmaceutics 1. It is a very important topic and we have to be get clear concept on this topic. So we are starting the journey right now. First of all, we have to know what is refraction. When a ray of light passes from one medium to another, a changes in direction happens and that it is known as refraction. If the light passes from a dense medium, if it is less dense medium, for example air, to a denser medium like liquid, it refracts towards the normal. And the bending also happen if it is opposite. We are telling the light passing from a less denser to the less dense medium. So the refraction happen away from the normal. So this is the basic concept of refraction of light. Next we have to write about Snell's law. Snell's law will give a representation about refractive index. So the refractive index have to be written by neta or small n, one sign elongating like that. So it is a constant ratio of sine of angle of incidence to that angle of refraction. So we can given by the equation neta is equal to sine I by r, where I is the angle of incidence theta and r is the angle of refraction. Wherever you are writing any equations or representation in PAP, you are supposed to write what are those terms. So we can tell like that this refractive index is a characteristic of a liquid. So first of all we written the Snell's law, then we are supposed to write about according to wave theory how the velocity parameter will change. Like velocity of the light decreases when it passes from a rarer medium through a denser medium. So again we are writing with the help of an equation. Eta is equal to velocity of light in vacuum divided by velocity of light in liquid medium. Normally, the refractive index is greater than 1 for the substances denser than air, because if it is denser than air, the numerator part will always come high. So the refractive index value will come above 1. Next, we are thinking about what are the factors affecting refractive index. Refractive index varied with the wavelength of light and temperature. So it is represented by eta d20, where this symbol indicate the refractive index at 20 degrees Celsius. That is the superscript R, and the subscript represent it is passing, or we are using the D line emission spectra at 589 nanometer. So how we are going to explain the factors? So it will depend on the temperature as well as the light source or the D line spectrum we are using. So we have to know some of the basic example for the refractive index. At least we have to write with an example. It will improve your mark. Like methyl acetate refractive index is 1.3, or ethyl benzoate. Anything you can write as an example. And you have to note like that most of the refractometers has a provision of jacket surrounding the prism for the Walker circulation. So next we are going to tell about the measurement of a refractive index. So refractive index is determined by using the instrument. That instrument we are calling it as refractometer. So many refractometers are available. Abyss refractometer, immersion refractometer and full bridge refractometer are the common example. And normally we are using some liquid for the calibration for the refractometer like CCl4, toluene, distilled water, etc. For the distilled water, refractive index is 1.3. So among this refractometer, we are using Abbey's refractometer as the commonly used laboratory scale because of some of its advantages. So these are the parts of Abbey's refractometer. So when you are drawing, should be clear diagram should be there. So this is the reflective mirror. Then this will pass through the prism box. Together we are calling prism box. So prism A and B are the part of that. It is surrounded by a water jacket, and one scale is the telescope and magnifying glass. So these are the parts of refractometer. So just now we said like that Abbey's refractometer is the mostly used because of some convenience. Like it should be a reliable one, it should be a simple instrument, and for this refractometer we only need a small sample requirement, and it is suitable for most of the range of the substance, and we need only an ordinary light source, and we can easily maintain the substance economy is easy. So these are the promotions, how or what are the advantages which help you to select Abbey's refractometer mostly. So as we already mentioned, these are the part of the Abbey's refractometer. Once again, they are refined light reflection mirror, water jacket, mirror or prism box, telescope, and magnifying glass. So what we are doing is that, as we already said like that, first we are supposed to prepare a drop of liquid whose refractive index have to be done, and we are keeping the drop of liquid upon the surface of our prism. Let it be prism A. So when we are keeping the prism or clamping the prisms A and B, what happens is that the liquid that is spread on the prism A will spread as a thin film. So we are having the reflective mirror down, right? So the mirror M reflects the light, and it directs towards our prism system. When it reaches the ground surface of our A, light is scattered into the liquid film. But at that time, we have to consider one more thing, because at that time, a particular ray going along a particular angle, because at that time, the angle is coming less than 90 degrees when it passes through the prism. So we are calling at that time it is less than 90. We are calling by another term as critical angle. So we want to know what is this critical angle. So according to critical angle phenomena, so we have to draw as an extra part of this diagram apart from the Abbey's refractometer if we are getting Abbey's refractometer. So sin E is equal to small n by capital N, where small n is the refractive index of the liquid and capital N is the refractive index of the prism. So we have to find out the critical angle emerging from the upper prism, and with the help of this critical angle we are able to find out the refractive index by the mean of our telescope. Actually what happens is that this telescope is fixed and this prism box is rotated. So what we will get the critical angle with the help of the cross wire of our eyepiece. So we can say the refractive index, and it will give a definite value of our refractive index. So actually what we are seeing through the telescope, we are seeing as two portion, like a bright and dark portion, and when the edge of this bright portion coincide with our telescope wire and all, what happens is that we will get a particular scale at what range, 1.2, 1.2, like that we will get a range of refractive index of our respective liquid. So for everything like that, we are supposed to know what are the application of this parameter. So we are studying this refractive index under the physicochemical properties coming under your states of matter unit. So we are telling what are the applications of refractive index. First of all, we are telling like that Refractive index is used to identify a substance. It can also help to measure the purity of the substance as mentioned by pharmacopoeial standards, and also help to find out the concentration as we are doing in the QC quality control test and assay. And we can also find out the dielectric constant. So we have studied refractive index, right? So we can find out the dielectric constant epsilon. So we give one equation is like this: epsilon is equal to eta alpha square. So it will give a parameter. So if you are finding or if you are noting this refractive index as large wavelet, we are supposed to get the dielectric constant. And apart from that, we can also find out the molar polarizability, that is alpha P of a nonpolar substance. So using this equation, we can find out induced polarizability, and it also helps to calculate the molar refraction without conducting an experiment. That is the important thing. Molar refraction, because it will give a structural features. So it is a relation. So molar refraction, this R we can calculate if you know the refractive index as per this Lorentz and Lorentz equation. So if you see the equation, you just keep it in mind. It's a give a parameter that connects the molar refraction as well as refractive index. So these are the main part of refractive index. I hope the concept of refractive index is clear. If you find useful like that, please share to your friend circle. Thank you for watching.